Hey guys, welcome to this session by Intellipaat. Splunk is a software for searching, monitoring and analyzing the machine-generated big data and analytics tools for accessing and investigating the potential threats by injecting event logs from multiple sources. Today, every organization generates huge amount of machine data, and this machine data is generated by applications, servers and networking devices that power your business. So understanding this machine data is hard and time consuming for an end user. But if it is available in the form of graphs, tables and dashboard, it becomes easier. So this is where Splunk comes into the picture. It transforms the machine data into valuable real-time insights which is available in the form of custom dashboards. So today's session is all about Splunk. Before moving with this session, subscribe our channel and press the bell icon so that you can get the notification of our latest videos. So let's have a quick glance at the agenda. We'll start off by understanding why do we need Splunk. Then we'll look at the components of Splunk and understand its working mechanism. After that, we'll have a demo session on indexes. Then we'll look at its licensing. And after that, we'll look at Splunk's distributed management console. And finally, we'll have a quiz to recap whatever you have learned in today's session. So put down your answers in the chat box so that we can get to know whether you have answered correctly or not. You can also put down all your queries in the comment section and we'd love to help you out there. So without much delay, let's start with the session.
So before moving to why we need Splunk, let us actually see what Splunk is. So have you heard of the word Splunk? Splunk is a software or tool that is used to analyze the machine data. But have you ever thought that why do we have to analyze the machine data? You must be aware of the exponential growth in machine data over the last decade. This was mainly because of the growing number of machines and the usage of IoT devices. And analyzing the data is needed because the solution to different problems is hidden in machine data. Analyzing this machine data will also help us to understand the customer behavior and the requirement, which will in turn help us to provide better service. This machine data will help us to alert the system admins about any security issues and system failures. Analyzing machine data also helps us to improve machine functionality. However, analyzing machine data is not a simple task. So how do we do that? Consider that you're working as a system administrator in some organization. So in this organization, the data can be generated from different sources, such as sensors, network devices, cloud services, Internet of Things, and mobile services. And the data generated from these resources will be in the form of unstructured machine data. For example, machine data looks something like this. Let us say there's a failure on one of the systems and you have to find the solution for it. It will be very difficult for you to find out in which step exactly the hardware failed the program. So machine data is not only complex to understand, it is also in an unstructured format, and it is also not suitable for making analysis or visualization. So what do you think? How can this be resolved? So in this case, we need a tool that understands machine data and helps us in identifying where exactly the hardware or software has failed. So as we have discussed already, this can be resolved by using Splunk. So Splunk is a tool in which the machine data is processed to extract the human readable form of data. And this will help us to analyze the problems. So whenever we are looking for state of any software or hardware, we have to search for the log file. Now Splunk can be seen as Google for log files. That is, Splunk makes machine data available to infrastructure. The primary components of Splunk are forwarders, indexers, and search heads. Forwarders are responsible for collecting the data and forwarding it to other Splunk instances and indexers. Indexers help us to store and index the data. However, we cannot just access the data from indexers. We need to have search heads which will help us to analyze, visualize, and report the data. Now, Splunk will help the users to leverage the machine data in analyzing the system performance, identifying the failure conditions in the system, monitoring the business metrics, searching and investigating a reason, visualizing the data and creating dashboards of results, and storing the data for future references. Now, let us see how Splunk works. So we have data that is stored in machines, which can be in the form of logs, databases, views, or API clauses. On the other hand, we have users, who act as information dividers from various sources. So the business operations need graphs, images, pivots, and dashboards to make better decisions for business. So what do you think? What is it exactly that acts as a bridge between data and users? Yes, it is indexes. Or you can think that it is a table of databases, and this is how data is stored in the machines. So once we store the data, we can extract the data using search processing language or SPL. So all the data in the machine will now be stored in the form of event. Once this data is retrieved from the machine, you can edit, calculate, or consort according to your need. And this technology is not only easy to implement, but also provides a wide spectrum of services to its users. Some of those are indexing data, facilitating searching and investigating, mapping knowledge to search, scheduling alert, and preparing and sharing Splunk reports. Nowadays, we have seen storage devices get better and better over the years. So we have also seen processors become more efficient with every aging day, but there is no data movement. So Splunk is a handy tool to bring in data movement. Now you might be wondering why organizations are opting for Splunk. Well, here are some of the benefits of Splunk. It started working as Google for log files. That is, you can input the data in any form. Splunk searches using simpler terms with the help of search processing language. It does not require any backend or any database as it stores data directly in the Splunk file system. Not a single point of failure is encountered. So apart from the above mentioned highlights of this technology, there are a lot of features such as fast installation, easy scalability, retention without losing granularity, and so on that give this technology a distinctive competitive edge. Some of the major Splunk customers are Vodafone, Domino's, ING Bank, and New York Airbrake. So Vodafone is a telecommunication company where a huge amount of customer data is generated. Hence, Vodafone uses Splunk to manage this big data to optimize and provide better customer support. Domino's has also opted for Splunk to understand the customer behavior. ING Bank is using Splunk to troubleshoot the key apps and insights into customer behavior. New York Airbrake saved almost $1 billion in a month by implementing Splunk. Now let us move on to the use case and see how Splunk helps organizations to resolve their issues technically. You might be aware that Domino's Pizza is a fast food giant, but are you aware of the difficulties and challenges they were facing? So they wanted to understand the customer needs and cater to them more effectively by using big data. Domino's database used to generate a lot of unstructured data, which led to difficulties in maintaining them, such as errors in manual searches, differences in preferences, and many more. So this was resolved by Splunk. Splunk helped Domino's to search the data faster, monitor the performance, and get better insights. It helped Domino's to set up interactive apps, get real-time feedback from the customer, analyze different payment methods, and monitor the performance of the in-house sales team. Splunk's widespread applications and ease of installation have made it immensely popular in the field of big data analytics. From a low-profile big data company to one of the most popular technologies, it has been successful in creating a solid impact on the leading tech players. Now, let us look at the hands-on exercise where we learn how to add data in the Splunk tool. So to do that, we would have to log into the Splunk Administration. In settings, you see there are two options. One is add data, which obviously helps us to add data and also to monitor the local and remote resources. Then we have a DMC or Distributed Management Console, about which we'll talk in detail later on. So in add data, you see there are knowledge objects. These could be searches, reports, and alerts. Then we have data models, which are basically structured formats with which we can build dashboards and reports. And after that, third in the list, we have event types, that is different type of records which get registered, which help us in optimizing our searches. Then we have tags, fields, lookups, and multiple other options, and we'll look at all of them later on. Next, we have some system settings like server settings, server controls, and licensing. Then under data, we have data inputs, forwarding and receiving, indexes, report acceleration, and source types. Then we have distributed environment. So if you're using multiple servers or multiple hosts, then we'll be using all of these options. So finally, we have users and authentication, that is access controls. So let's go ahead and start with data input. Since it's a standalone system, we are not specifically looking for a remote source from where the data is coming into the system. So what we can do is we can actually configure some local logs. So you can see there are multiple options over here: remote event log collection, local event log collection, files and directories, and local performance monitoring. And since this is actually a Windows environment, there are some readily configured files available. So we'll go to files and directories. So by default, Splunk creates some indexes for its internal data repository, and these are used to assess the application health. So you can see there are mappings of some of these directories like Splunk version, and all of this directory data is going to the destination index with a specific source type like Splunk version over here. So you can see Splunk version, introspection, Splunk, pool, stash new, and each of them is mapped to a destination index. And not only this, there are also multiple files for each of these paths. So you can see data is being populated in each of these indexes. Now, since we want to add our data into this, so what we'll do is we'll go ahead and add our own local inputs. Now, instead of local inputs, we can also have forwarded inputs too. And since we're not using any remote resources, and since this is just a standalone machine without which we cannot have access to any remote machine, so we'll just be using the local event log collection. So these are the available Windows logs which can be collected and taken leverage of, and these are the available indexes. We can actually create our own indexes, that can also be done. So first let's select some logs from specific sector of this machine. So I actually want application logs, and we'll map this application logs to the main index. So just to reiterate it, I am selecting all of the application logs and I am storing or mapping them to the main index. And let's actually go ahead and save this. So I have an index now which is readily accessing data from the application logs. Now I'll go to indexes and see how many indexes are actually there and what is the current size of those indexes. So as you can see, these are the list of indexes that are already there. Any index starting with underscore is actually a Splunk internal index, and these won't show up readily in our searches. So what do I exactly mean by that? Now let me ask you a question. Why are we using Splunk? So we are using Splunk to aggregate the data, optimize it, and store it so that when users have to correlate some events and search for some specific events, then they can write their query and get the data out from the Splunk database. But what is happening is there is a lot of internal data getting stored, and we don't want that internal data to be shown in the Splunk searches. And that is why indexes which actually store internal data start with an underscore so that we can distinguish it from other data. But history, main, Splunk logger, and summary will show up if the data is in your search query. And we can actually also see the event count for all of these indexes. So these are all the event counts over here. And since we have mapped the application data to the main index, all of the data is stored here. So starting from 5 months to 23 days ago. And this is how we bring the local data into Splunk.
So let's go to settings. The settings, you see there are two options. One is add data, that we were talking about is adding data or how to monitor the local or remote sources. and there is a DMC, which we'll be talking about in detail in due course of time. In add data, you see there are knowledges. These are the knowledge objects we have been talking around. It varies from searches, reports, and alerts. Data models, which again is a structured format in which you can build dashboards and reports using these models, data models. Then you have event types, is the different types of events that gets registered, and you can take use of it to make your searches more optimized. You have tags, fields, lookups, and multiple other things which we will cover in the knowledge management classes. Next, you have some system settings, under which it comes server settings, server control, and licensing. Again, we'll come to this. Then under data, you have data inputs, forward and receiving, indexer, report acceleration, source types. This is the basic of data. And distributed environment, if you are using multiple servers, multiple hosts, then you would be using all these options. And finally, user authentication, that is access controls. So let's start with the data input. Since it's a standalone system, where we are not specifically looking for a remote source from where the data is coming in to the system. So let's configure some local logs. Let's start monitoring some local logs. So you can see that you have multiple options over here: remote event collection, local event collection, files and directories, local performance monitoring. So these are multiple types of files. So since it's a Windows environment, some readily configured files you can see already that has been taken into consideration. So this this is like by default, Splunk creates some indexes for its internal data repository, and using these internal data to assess the application health. So you can see there are multiple, it's mapping to some of the directories, and all those directory data are coming to a set of index with a specific type of source type. So you can see the Splunk version, this is introspection, you have Splunk logs, you have spool, and you have stash new. So each of them comes to some index, set of indexes, and they already started indexing. So you can see multiple files for each of these paths. That means you should see data populating in these indexes. So we'll get to that. So what we'll be doing now is adding our own local system. So these are the local inputs, whereas we have forwarded inputs as well. Since we are not using any remote sources, as I told, it's a standalone machine without access to any remote machine, we'll be using the local event log collection. So we will go to actions and go to edit. So these are the available Windows logs which can be collected and taken leverage of, and these are the available index that is already there. You can create your own index obviously, but as of now we have this. So let's do one thing. First, let's forward, or let's have logs from some specific sector of this machine. So let's have maybe application logs, and let's start indexing that log into the main index. So I have just clicked on the application log, so it's a selected log now, so it's the source now, and where does it get indexed? In the main index. I will save this. So I have an index now that is readily indexing the data from application logs. And I'll go to indexes and see how many indexes are already there and what is the memory current size of those indexes. As you can see, these are the list of indexes that is already there. Any index starting with underscore is Splunk internal index, and this won't show up readily in your searches. The results from these indexes won't show up readily in your searches. So by this, what do I mean? So basically, why are we using Splunk for? So it is aggregating the data, optimizing it, and storing it. So that the users, whenever they need to correlate some events, and they need to go and search for some specific events at some point of time, they can write their own query and get the data out from the stored Splunk database, you can tell, yeah, unstructured database. But there are a lot of data that is getting stored, the internal data that is getting stored, that we don't want to show up in the Splunk searches. That's why those datas are starts with underscore by default, and these underscore, though not those data, sorry, those indexes with internal data in it start with underscore in the first case, as a first at first, before in fact the alphabets. So this is because these indexes won't show up if you're searching regularly for the data. It will only show up if you specifically mention the underscore and after that the index name. But history, main, Splunk logger and summary index will show up if they have data and if you have not given any specific indexes in your search query. So as you can see, this many indexes are already there, and we are already seeing event count is pretty huge in some of them. Those are mostly internal index, and we can see, since we have given the application data, everything got stored in the main index starting from 5 months ago, maybe the point of time when the machine I'm using is in use till 23 days ago. So it's not, there is no much changes in the main data logging, so it's all some past data, whereas we see the internal data for audit, internal introspection got started generating some minutes or seconds ago. Okay, so let's create a new index. So we can specify the name of index as test or Splunk test. So here, this is the path where the index will get saved. So there is very interesting thing that you can see is index name, and after that you have the home path, cold path, and thought path. So these are the three different paths in which different form of Splunk data will get stored. Again, there will be a separate session on the retention policy and the buckets, which is directly related to these paths. But as of now, just for reference, I'll tell you the home path is the hot bucket or warm bucket. So what is that? That is the real-time data that is coming in to your system. So that data needs to be stored in the home path or get stored in the home path. Whereas cold path is the data that is not real-time data, and this is something as per the policy, as per the configuration, this is there's some different directory where the data will be stored once the home path is fully utilized. So home path has a specific limit of storage. So once that storage is exceeded, it will move to cold path. There are some other factors as well. It can exceed the threshold, or you can only tell that the number of buckets that is already in the home path. If it exceeds that, it can come to cold path, or based on the timings. So after 5 days, it can come to cold path. So there are multiple declaration based on which the data can be transferred from home path to the cold path. So the basic difference between these two paths is that type of data that is getting indexed in here. So the home path has the, as I told, has the hot or warm data, which is mostly the real-time data or the fresh data, which is very easy to search because it's very optimized and rich data, which is having all the metadata with it, and the compression is less, and you can easily do some real-time searching with it. Whereas cold path is something where it's the intelligent data minus some attributes which make it a bit slower to search for, but even then it's searchable, and it can extend from maybe 1 month old data till 1 year old data. So that much data can be stored in cold path. So the difference being the home path storage is a bit expensive, that being because home path is very fast, and home path data, for each data that we indexed, the home path utilizes more memory, but cold path utilizes less memory. So the stale data needs to go to cold path, because we don't use it on regular basis, but we might use it from time to time. That's why cold path data is a bit slower, but still it's there for you to search. Whereas thought path is, again, when cold path limit is exceeded, when threshold is breached, it goes to thought path. The thought path, by default, if you don't define anything in here, it will delete the data. So suppose you have kept home path retention policy as 1 month. So after 1 month, the data from the home path will be returned to cold path. And cold path retention policy you have kept as 12 months. So after 12 months, the cold path's data would be going to the next, that is a thought path. But if you don't give anything, if you don't mention any path over here, so it will delete that data. But if you mention a specific path, then it will compress the data by a more extensive ratio, and keep it in a thought path. So basically thought path is much more compressed data than cold path, and it cannot be searched on a regular basis. So it can only be searched when this thought, when that frozen data, which is completely unsearchable, that is brought back to thaw. So that is done by adding the metadata with the raw data, and that takes a lot of time. So thought path is basically used as a backup in case you have to use a very old data, but by default, if you don't mention anything in the thought path, the data will get deleted. So here even if we don't give a specific home path, it will take the default DB. So where does it get stored? I'll just show you from the folder or from the Windows point of view. So it will go to var lib Splunk, and if you come to this path that I just came from, till Splunk is the home path, and after that is var lib and Splunk. Here you can see all the buckets are listed. So you have the internal DB that we were talking about, introspection, the audit index. So these are different indexes. This auth DB is again for authentication, fish bucket, hash DB, history DB. So these are different indexes. So the default DB is the one we are talking about here. In this, the DB is the hot bucket path or hot path. So we were talking about the home path. So DB is the home path. Cold DB is the cold path, and thought DB is the thought path. So we don't see any data over here because nothing has been thought as of now. We should not see anything in cold DB as well, because yes, we have just started indexing the data, so we have not declared any retention policy. So we don't see anything over here. Whereas DB should have a considerable amount of data, and yes, that's what we see. The hot DB is locked because you can't change it. It's still writing the data. But yeah, you can see when it got written, and these are the files that are getting written. So there are, you can see that these are being written in two forms. There's raw data, and the TCIDX files, which are the metadata, the rich data that is searchable. So you can see the format as TCIDX. So this is the data that we are going to read by the Splunk web. So if we don't mention any path in the Splunk web, it will automatically go to the default DB. So that's why I'm not giving any specific path over here. Data integrity check, that is if you want to check the integrity of the data on every bit by bit basis, then you have to enable it, but as of now we don't need it. Maximum size of entire index, so this is the maximum index size, so we are keeping at some high, very huge value. So as of now it's 500 GB, so we'll keep it that way. So maximum size of hot or warm bucket or cold bucket, so any of this we are keeping it auto. So we are not defining any value over here because we are keeping it pretty high by default. Again, frozen path is not defined over here. So if it's not defined, then as I told you, data would be deleted beyond cold bucket. So these are retention policies and reduction methods which we don't want to get in as of now. So TCIDX, already we have seen the file format, that is a searchable data format, which is the feature rich metadata. So let's save the settings. Instantly we can see there is a Splunk test index that is created. So let's try to shift some of the data to Splunk test and see how it works. So let's again go back to data inputs, go to the local event collection. So let's now select security data and give this Splunk test as the index. So if we have any security event in the system, it's supposed to get logged in here. So let's go to index and see if we have any. Uh, so we do have only one incident event in the Splunk test. So let's see what's in it. So let's get into the search and reporting app. So it will take you to a page where you have the search bar. So we'll talk more about this setting, but let's see what is that one event in the Splunk test index. So I'm just writing a basic search where I'm just declaring the Splunk test index for all time and hitting on the magnifying glass. Okay, so we are seeing a lot more events than we were seeing over there. So a lot of the data should be getting indexed as of now. So let's not get to that huge. So let's keep it to last 60 minutes. I don't think we should be seeing any. So let's keep it to last 30 days. So this is the part where you can select the time window. We'll talk about it again. So we have an event on 9/4. Okay, that's today. We do have an event and it shows up with a lot of data, so log data that's within that. And in the left you can see the source. This is a source from where the data is coming. So it's win event log security, the source tab being the same. There are multiple applications that might be part of this log, and you can see hundreds of other fields that has come up over here. So this is from the search that we have done. So if now you want to see, so what is the task category? So there are multiple tasks that is distributed over the entire logs, and you can see multiple fields that has come up, right? So let's see if something can be taken leverage of by us, any meaningful events that we can see as of now. So these, obviously everything is meaningful as long as the right people is looking into it, but as of now these are masked test data, so we might not get a lot of information out of it. But this is how the search will happen, and this is a proof that your Splunk is working properly, the data is getting indexed. So that was just Splunk test index. So we'll again go back to indexes and see what's the count, and we see a huge amount of data has been indexed. So wherever we are seeing only one event count, now we see a lot. So the moment we enabled the security logs into Splunk test, the data started pouring in. So you got an hint of how these indexes are created from the web. You can do the same from the backend also, that is directly walking into the config files, which would be a bit deep inside, but let's just give you a quick overview on that. So these are multiple folders or directories where the config files are located, and we will go to Splunk local directory and to the inputs directory. So we have the host name over here, and if we go to the server directory, we should see, okay, we don't have that here. So should be in the default. So let's see, where is this index.conf got created. Okay, so it got created in the app level. Interesting. So you can see that the index that we created is Splunk test is having all the features over here. So the cold path that we have not defined is here, and it's the default DB they have taken. And different other factors which we have disabled is 0, that is disabled. The home path is also defined. Actually, they have created a new path for each. So let's go and see if actually it exists or not. So if we go to the Splunk home and go to the var and lib, you should display a Splunk test directory created, and yes, it's there. So the indexes that we have created automatically created a separate section back in the config files. So we can see a Splunk test directory that has been created with its hot and cold database. So these are the data that is getting written right now. So we should not be touching it, but we can obviously read all this TCIDX. So as you can see, the data is getting populated even now. So it's a huge amount of data that is getting written, and again it's getting formed into a simple structured file which we can read through the Splunk web. Now let's get back to the Splunk web. So the backend, I have given you a sneak peek on how does it work and how things are interrelated. We'll talk more about the internal and default system default and system local config file configurations. We'll come to all those features. As of now, let's stick to the Splunk web. I just wanted to show you how things are correlated. The things that was not there, the moment you created something new, it gets saved in the backend. So we created a new index, we installed the Splunk, we configured input in the standalone server. Now there are some other factors that you might be interested in, one being the forwarding and receiving, which we won't be using plainly for the reason that we are using a single standalone server without having any remote access. So we won't be enabling any of these settings now, but I will show you how it can be done in a distributed environment. So as we have already talked, right, the three main components of Splunk Enterprise, and I'll also show you in this diagram, is the forwarders, the indexers, and the search heads. The forwarder forwards the raw data to the indexer, and indexer stores those data after passing, and different queues are there. Obviously there's a data pipeline that comes into picture, which is having the parsing queue, the merging queue, the typing queue, the index pipeline queue. So these all are there. So these all queues are there, which is parallelly some processors that are running in indexers. Some a part of it running might be running in the forwarder as well. And once the data is stored in that indexer, the search head can go and request some objects. Suppose you go into a search head and you try to run a search. So the search head requests the set of object that you have requested for to the indexers. Indexer will give it back to the search head as in the form of request, in a form of message, and it will be popped up in your screen in the Splunk web. So that's how all three interrelates between it's interrelated. So this is a basic architecture. So but this is the architecture of a distributed deployment, which we are not doing as of now, but I'll give you a hint on how exactly to set it up. So as you can see, indexer is remotely receiving data from the forwarders. So how does it does that? So how it happens? So it basically happens by opening a port. We have already talked about Splunk ports. So now we are gonna see how it's done. So if you see, you have two different sections over here. One is forwarded data, one is receiving the data. So configure receiving is something that indexer needs to do. So it receives data in a single port. So once you click on it, it will show you there is if there is any port open for not for this. So if you want to add a new port, you just mention a port. So by default, indexers listen or Splunk listens on 9997 port. So you save this. So what does this mean? This basically means that you have to all the forwarders that is out there ready to send their data to their indexers, you have to point those forwarders to this indexer and this port. So there are there are almost some 6,000 ports that is out there that can be used, but not even six, it's more than that. There is a huge amount of network ports that can be taken leverage of, but we are using 9997 port as the receiving port to which the forwarder would be sending their data to. So if you have a IP address or if you have a host name of suppose Intellipaat 01 as the host name of the indexer, so you will tell your forwarder to send the data to Intellipaat 01, then you will have a colon and you will give the port name, that is 9997, and forwarder will start forwarding the data to this port of this host, and immediately the indexer, if the relevant host port is open, it will start receiving the data and writing it onto the disk. So that's why configuring receive reception or the receive the data is very important. So I'll just disable it because these are network ports and I should not be opening it until I have a very authentication in place. So I just disabled it, but it can be used to listen to the data that is getting forwarded. Similarly, the same setup can be used for a heavyweight forwarder, which can receive the data and also forward the data. So you can, since the heavyweight forwarder take leverage of the same Splunk software, so the entire setup is there. So basically what you have to do is you have to configure forwarding, where you have to give the link of or the host name and port of the server where you are sending your data to. So basically think it as your forwarder setting. So as I told you, in the forwarder you have to mention the host name and the port to which you are sending. So this is something we are doing now. So this will be the setting in the forwarders end. You will give the host name of the server you are supposed to send it to, and also the port to which you are directing the messages. The moment you save it, Splunk will start sending its data to this host or this server to this port. So this will start sending the data that the intended data that we're planning to send off to this server. Again, I'm disabling it for the security of the system. So that is the forwarding and receiving, which is used in the distributed deployment, where the forwarders will have the forwarding setup and the indexer will have the receiving setup. So and they has to have the same IP mapped so that they are getting the right amount of data is getting addressed to the concerned servers. Next we got reports acceleration summaries, which we won't be touching as of now because this have a totally different presence in the knowledge objects as well. So and just I can explain you that report acceleration is something that is used by the knowledge objects to speed up their searches. So instead of having a delayed or a search taking a lot of time, if it's have the report acceleration enabled, those searches will be completed very soon, and these are done for very premium searches. You should not be using it for all the searches because this will eat up a lot of space in that case, but it can be done for a very premium set of searches which is on high priority. So even though eating up some space in favor of getting quick maybe result is acceptable. Again, you have the source type as well over here. So source type is something that we'll be covering in the respective classes. You can see some default source type already declared over here, and you can create your own source types as well. Source type is again another parameter which Splunk uses to identify data types. So as we talked about that, as we give index, right? So we just created an index which is basically showing, which is basically storing a different set of data or a specific set of data. So now that data can be coming from a single server, but from different files, the data can be coming from. So those files, each of these files, you can define different source types so that you can easily search across those data in times of in your reporting or in your dashboard. So this is basically a selective filtering method that is being used, which if the more maybe the more exact your filtering is, the more you use the key value pairs in your searches, the better your search comes through. The source types is pretty handy in those cases. So next you have again index the factors that is relevant in a distributed environment, but even then I'll be showing it to you and how does it work. So first let us go to the server settings in the system. So there are multiple things that you can see over here. There is a general setting, the first of it. So it has some server names declared over here, the path where it gets stored, the management port. The management port is, again, as we have already discussed in the previous classes, this port is used by different Splunk components to manage other components. So it can be used by the master cluster master port to manage the indexer, or the deployment server port to manage the forwarders, or the deployer can use this port to manage the search head cluster. So this 8089 is the management port that is used by different Splunk component for different purposes. No, basically the purpose is management, but they handle it in a different way. So we have this Splunk web running, so it's yes. We have not enabled SSL, which we can enable. Instead of using, in that case, instead of using HTTP, we'll be using HTTPS. So we can obviously do that. The default web port is 8000. That's why you can see over here it's 8000 is there. If you change it to something else, it won't work. But if you change it here, and the same can be used over here. So let's do that. So suppose I use it 8089 you can't use, so let's change it something like 7000, and let's save it and see how does it work out, and if at all it works. The moment you change something significant, you will see a message popping up that this requires a Splunk server restart, which you can do readily from here. Server control is there in the settings. You have seen server controls, it will take you to the same page. So instead of restarting the server from the backend or from the CLI, we are doing it from the Splunk web itself. You can obviously do it from the CLI. So let me show that event to you. Open the command prompt in administrator mode. Go to the directory where the Splunk is installed. Go to the bin folder which contains all the executables. Now you want to see the status of your Splunk, and you write the command, and you can see it's showing as stopping. That is how it is because we have restarted the Splunk and it is initiating a stop and start mechanism. I type the command once again. So now it's stopped. So the Splunk is stopped. So this is the process in the Splunk restart itself. We are expecting it to get started soon. And as it's told, it's starting with a new PID. So let's try 7000 now. And yes, we do have our port changed to, the web port is changed to something different. So now we are operating at a 7000 port instead of the regular 8000. So you can obviously play around with all these features. The management port, it's advisable not to change it, because that's a default port that is used by a lot of critical Splunk components. So we should not be basically changing the default ports. I just wanted to show it to you, that's why I changed it. So session timeout is the time after which a non-responsive Splunk will actually time out. You have the host name, you can configure it, the path you have been given, and also pause indexing if free space fails below this. So if the free space in this disk falls below 5 GB or 5000 MB, the indexing will be stopped. So you can decrease this in times of crisis. So suppose at this moment the data is indexing, and suddenly you don't have enough space in the disk, and you don't need this much of a leeway, you don't need a 5 GB of leeway, so you can obviously change it to 500, and immediately you can see the data will start re-indexing. But it's safe to keep this huge leeway space, because it can be used at times of need. So we will keep it as it is. So that's all in general settings. Email settings basically you won't need, because this will basically trigger a mail in case Splunk is down or something else is not working out. So this is a mail that will get triggered to the administrator. What else you have got? Server logging. These are different logging levels. We see everything is in warning until it's critical. These are fine. These are by default. Now that is something is deployment client. This is again a factor in the distributed deployment. So I'll tell you what it is in a very short overview. So these forwarders, right? Some of the deployment. So we already talked about deployment servers, which handles multiple forwarders. So each forwarder in that case will act as a deployment client. It instead of manually changing the settings or configuration in each of these forwarders, by going to each of the manually and changing it, the deployment servers does it in at one shot. So for that reason, you have to turn the deployment client feature on. The status should be enabled, which can be done only from the backend, which can't be done from here. But since we don't have multiple server again, we won't be setting it up. So what you can always do is, how it you can use it is, all you have to do is go to etc, then system, and then local, and here you have to create a configuration file as deployment. So sorry, it's a folder that I have created by mistake. So let me create notepad which will have a feature called this, and you give the IP address of that deployment client, so be it anything. So as of now we can keep it like x.x.x.x, and you save it as deploymentclient.conf. And the path you would be saving it to is in here. The moment you does that, and after that, let's see if it works, even though we don't have any. So let's start this time, let's start it from the command line. So it shows running. All we have to do is restart. It will take a while. So let's wait and see how it works out. So these are mostly the features of a distributed deployment model, which needs a proper Splunk license. As you see, the license is pretty heavy to come forth. So it's pretty expensive to buy that license and leverage it. So we can see in the back end, the Splunk is restarting. So that's why we are having a very a single server model where we can try out the very basic stuff, and we at least have an idea how the entire distributed deployment how the Splunk deployment works at least. After that, we can try the same for a distributed deployment model. As you can see, we are starting the Splunk daemon service, the main service, the Splunk D, which is behind all this. And next, it should start the Splunk web as well. So we'll talk, there's a lot to talk about Splunk D as well, which works in the back end, which controls all the stuff, which handles all the processes, all the backend stuff. So it's immense powerful. It's a performance packed component which is basically doing all the work. So we have server up. We just logged in. Let's go to server settings. Okay, we don't see it enabled. I guess it's not finding. First of all, we have not declared a proper IP, and even then, even if we have declared, since it's not a distributed model, I don't think we will find anything relevant. So I'll just deploy. Okay, I did make a small amount of mistake by not giving it the proper name. Let me delete the previous one. And let's try restarting once again. This time again from the web. Let's see if it works. The only thing I'm trying to see is if that arbitrary value really holds up for a reason or two. So these are all the Python scripts that is working in the back end, keeping this Splunk up and running. So you can see most of these are Python script. There are other scripts as well. So these all are components of the Splunk bin directory. You can use the command line as well for configuring your Splunk. These are all the listed apps that you see. Mostly some of them are add-ons which are hidden and we don't have a proper web interface. You only have it for the search. As you can see, the search app over here, and obviously you have the same for DMC. Should have been here, it's not yet here. So let's see. Okay, first let's sort this one out and see if it's working at least now. Let's go to server settings, deployment client. Okay, it won't get enabled because it's not finding the proper IP. So I just tried to experiment it out just to show you guys how it works, but it's not. So it will need another level of restart, but we'll do it at the end of the session. No more wasting of time here. Finally, you have search preferences. Okay, what to select by default. So normally you just saw that while we started a search in the Splunk web, it was by default all time. So you can change it here the way you want it. These are the presets. You have relative and real time as well. So the way you want it. So you want to keep the default as 60 minutes. You don't want every time you fire a query to go for maybe 20, all time. Then yeah, so next time you start searching a query, you will see just 60 minutes over here. So we just changed the default to 60 minutes from all time. That's good way of seeing it. Now I'll just show you server control. We just saw it's used for restarting of servers, nothing else. It's a premium button because you can basically you can trigger a restart from the GUI itself instead of going to the command prompt. So it's it's a button that has to be used very carefully because you are restarting the Splunk D over here. So here comes the licensing. So again, since we are working on a basic free license, it's a free software that we downloaded. Even though the software is free always for Splunk, the license is paid for, and that license comes primarily to you as a XML format, which you upload over here. If you see, so over here, change license group. Here you have different types of license. So the one we are using is enterprise trial license. So we only have the option to move to a free license other than the trial license. Free license will take a lot of will take from us a lot of features that we are using currently, because these features in the trial license are only available for 60 days. After that, by default, it will turn to free license. So as long as you have the trial license, you can use multiple features, but in free license you will lose all that. So let's keep it a trial itself as of now. You can obviously turn your Splunk instance to a forwarder. In that case, it won't do anything else other than forwarding your data. So this is used by the forwarders, which is not indexing any data, which is the forwarding, which is just forwarding the data. So the license usage in forwarders is basically zero. So you don't need a forwarder to come in the purview of the license master. That's why you, for any forwarder, you just keep it in a forwarder license. That means that that Splunk component is outside the scope of the license master. Anything else other than Splunk forwarder, that is the, be it the indexer, the cluster master, the deployment server, or maybe the search head, all of them having some local data inside them, the system data, they're indexing it to some extent. So all of them will come under the purview of the master license master. So that's why apart from the forwarder, everything else should have any of these three licenses. So the below two is the free, and the trial license are basically not used at enterprise level for a distributed environment. We are using it because we are using a standalone machine just for testing purposes and for some basic use cases. So we have these free and enterprise trial license, but for a complete distributed environment, you will have the enterprise license, right? So this comes only when you try to save it. It will ask for a file. As of now, we don't have any, so we can't select it. So it will the Splunk will provide you an XML which you can choose and upload over here. The moment you do it, it immediately will see some change of policies over here. So as of now, you can see that the license expiration date is 3rd of November. So we started on 3rd of September, and oh no, it started on 4th of September, so it's taking basically 1 day minus 60 days. So the license daily volume is 500 MB, and today we have already utilized 344 MB out of it. So 70%, almost 70% is utilized. So beyond 500, if it goes through, then there will be some alerts that will be triggered, and you might not be able to index it for the day. So we just saw how to change the license group, and we can see the usage report, the 70% data, how is it distributed. So you can see basically a dashboard is already prepared for us where it shows how much is license usage for today. So this is the quota in yellow, and this is the used one. The quota is around 0.5, that is 500 MB, and we have used 0.3. So we don't have any over usage, so everything looks beyond threshold, so we are good. Previous 30 days should be there should not be anything because today is the first day we are using this server. If you come back tomorrow and look at the same server, which we would be doing, so we would see some activity over the course of time. So this is how you measure your licensing, and this is how you turn one of the component to license master. So how do you do it? How does all the components in the Splunk environment assess the amount of license that is being utilized? So you turn all of the Splunk component to license slave. So you can change this server to license slave. The moment you do it, so designate the Splunk instance this as the master license server. So the moment you select, so this is auto selected. That means this standalone machine is a master license server already. You don't have to change anything. But if you had two instances of Splunk and if you wanted to make this one the master slave and the other one as the master, this one is a slave and the other one is a master, you had to select this option. So this is the one that I was trying to do from the back end. The folder, the configuration file that I was trying to create over here, that did not work out because we are not defining a proper IP, and that too we don't have any IP to define. That's why we can't see it over here, but that's what it will create when you do it from here. So you have to give the IP of another IP and the port address of another server, and immediately this server, the server we are in, will turn into the slave of the other server. And that way the master server can track the license usage activity of this server and what all servers you make slave, the other servers as well, which all will be the slave of that master server. So this is all about licensing. In brief, we'll cover multiple other things as well under licensing and how it can be scaled and it can be deployed in a distributed environment. But as a standalone machine, we have very limited scope in licensing. So if you remember that we have started Splunk in non-default port that was 7000. So I'll try opening the same port and log in the credential. So here it is, we are in the home page of Splunk. Our topics will be mostly on the DMC or the Distributed Management Console, the distributed environment, and users and authentication. So these topics I'll cover practical examples on some basic stuff, but there are respective separate dedicated classes on this which will have theory first explaining you the entire portion, and then a practical class that will relate what all has been told you in theory. So today let's go through an overview of all these parameters. So let's first start with the distributed management console. So this is one of the newest addition of Splunk, and this app is mainly built for monitoring of internal Splunk. So now we must be aware that Splunk is a pretty big shot tool which does a lot of range of activities, starting from security monitoring to operation intelligence to search correlations. So those things we are monitoring basically different platforms via Splunk. So Splunk is gathering the data and it's analyzing those data and giving you an output on your business requirement. But what about Splunk? So how does we make sure that it is in shape? So how about we make sure that nothing goes down within Splunk itself? So which basically will bring down your entire monitoring system. So Splunk, to monitor Splunk, this new app has been built, the built-in app, which gathers data from Splunk internal logs. So what it basically does is, so you have different log sources from which the data is coming to your Splunk enterprise, and those data are getting written to index and you are searching for those data. But what Splunk and DMC does is, it gathers those data internally of your server, of different network inputs that are relevant to the Splunk internal system. So there won't be any network system as such. So if you remember, we have shown you the indexes. So this indexes have the list of indexes that has been built within our indexers. So as you can see, we have not built anything as such, if I remember correctly. Or yeah, we did build Splunk test. Yes, we have built Splunk test, which is gathering data continuously. Currently the data size is around 400 MB. Most of the other stuff was all Splunk internal Splunk built-in indexes. So main is also having a lot of data within it. We have history, which is having not a lot of data, Splunk logger and summary. So these all are being used to gather the external data, non-Splunk data. But these first four indexes, which are having a precursor before the audit, so these all are internal indexes. So basically what they're doing is they are gathering the internal index logs. Now you might ask that why do I have to pay for the Splunk gathering the internal data? So let me clarify now itself. Splunk does not license this data. What all is the Splunk internal data does not get caught in the Splunk license. So suppose you have this volume of data, around 403 volume of MB of data already within your other bucket that is gathering from your different other log sources, and you have this huge amount of data that is from the Splunk internal repository. So you can clearly see that this will consume a lot of license, since it is actually a huge volume of data that is used for tracking the health of Splunk, and you might not want it. Your Splunk environment might not be huge enough for you to know all this, or you might always question that why do I need to pay for what Splunk is doing for its internal health purpose, because anyway you would expect that the system would run in perfection. So what Splunk does is it does not license this data. So this is there in your index. You can obviously play with it. You can run your searches and see what's wrong internally in Splunk, but you don't have to pay for this. So this is sort of free that comes with Splunk. So what you are doing is you are paying for the rest of the indexes and other indexes that you will make eventually, which will be logging your target data. So this is a great thing that they have come up with. Now let's get back to DMC. So the DMC is entirely dealing with all these four indexes, nothing other than these four indexes. It's either internal or audit or introspection or the fish bucket, out of which the fish bucket is relatively a small index, which does nothing else other than it maintains time stamping of, it basically maintains the record logs of the other indexes, all the other indexes. So suppose for an example, if you have a main index which is gathering data, and suddenly you have a hit a failover where for 1 hour the indexer was not available to index the data. So after 1 hour, when the indexer is back up, it will go to the main index to search where exactly it had stopped indexing the data. So till where it has the data, and after which it needs to start indexing. So you have a backlog of 1 hour data. So how to make sure that that 1 hour, exactly at what point of time the indexer has stopped indexing? So this fish bucket does that. So what it does is it inserts maybe a time quotient in there, by which you can easily assess that this is the point at which the data had stopped being indexed. So next, when indexer come and starts indexing, it will start off from that point. So these all is being saved in the fish bucket, so it has no other importance. So that's why the data size is pretty small. So other three, as you can see, it's pretty huge. Audit is audit compliance data, so obviously it will be lesser in size, whereas internal introspection has the hugest amount of data. So even though you have to run, you are not paying for the license, but you are paying for the hardware, because this data is eating up your disk, and you have to keep enough space to accommodate these data. So even though you are not paying for license, but eventually you have to pay if for the disk size, but you are doing it for your own good. At any point of time you can disable it, that's in your hand, but this is for your own good. This is for enabling the DMC, the internal monitoring. So as you can see, this is the DMC. What it is doing is it's showing the index rate. It's showing the index rate of the indexer. So that means that in entire stretch of data, remote data, or your target data, what is the rate of indexing, it's showing up the entire thing. So it includes the internal data as well as the external data as well. So next you see the license usage. So this is the license usage. So what it does is, on a day-on-day basis, it will show you that what is the percent of license that has been consumed for the day. So as we already know by now that Splunk assess its license on a daily basis. So if your license is maybe 1 GB per day, then this 1 GB is just for today. So suppose you have consumed only 500 MB today, and you feel that tomorrow that 500 extra MB can be taken leverage of. So you can't do that. So tomorrow, if it stretches beyond 1 GB, then it hits a warning. So we'll talk about all that. So it's on day basis purely. So you can't stretch your limits. You can't have a customized license that way for different days, different amount of data license. That is not possible. So it's a straight out license that comes, and you have to buy it. If you feel like you need more, then you can apply for more at your own expenses. But this is fixed on day out basis. Next, the disk usage. So what is the amount of disk it's consuming? So it's basically your local drives, or if it's being written to some remote drives. So wherever it's being written to, what is the volume of usage that has been taken off in the disk? As you can clearly see, it's already been given in the highlight as well. Next is the searches. So how many searches are being run? So again, okay, so if you come individually to click on this individual attributes, you can obviously go to this respective places and see what exactly is going on. So we can always ask that what are the searches? We have not configured any searches in Splunk as such as of now. So how come? Okay, so we don't have anything as of now. So what I assume is those searches should be the internal searches. Let's see in the jobs. I'll tell you about it as well. So correct. So you can see the application, the searches that are running, they are purely in the Splunk distributed management console. Yes, so these all are calling the DMC assets. Then we should be having multiple DMC. Yes, most of them are calling DMCs. Others should somehow be relevant in DMC only because we have not wrote any searches. So it's all taking from the Splunk management console. That is a Splunk distributed management console. So the searches that had run, so it's not running as of now because it runs only at some point of time, at a given time of the hour it runs. Every hour it might be running at some given point of time. We'll come to that. So as of now we don't have any searches running, but we have a pretty decent index rate of 4 Mbps. So at this rate the data is getting indexed in real time. This is the license that has already been consumed, the disk person that has already been utilized. Also, it shows a CPU usage, how much CPU the Splunk is using, Splunk process. So it's pretty high as of now because the indexing rate is also pretty high. So there is a backdrop for why it's happening. So since we have stopped, so it's a computer where we have stopped indexing while the Splunk is not up, Splunk web is not up. So today when we brought up the Splunk while at the start of the session, so instantly started indexing the data. And what Splunk does is, whatever data it will find in those log files, be it the past data as well, it will start indexing that. So currently the huge rate justifies the fact that it's not just the real-time data, but the past data is also getting indexed. So this will also happen to you when you are installing the enterprise. When you have started the enterprise installation and you have made up the licensing, you have started using the license usage, you will see for the first time you might hit a violation or you might hit a warning because your license would be completely consumed and you will need more. That is first for the first time because there might be a gap between your Splunk application up time and when the server was actually procured. So between that time there might be some server logs or network logs that has already been being stored in the log files. but that was not being written to Splunk. So the moment the Splunk has come up and you have all defined the Splunk input source files from where the inputs will be taken and all, so immediately Splunk goes over there, checks what is the most ancient file over in that drive, and it will start indexing those data. So immediately your indexing rate will shoot up, your license usage is shooting up, because you are assessing that specific day, you are taking consuming data for past days as well. So suppose it was for past 5 days or past 10 days, accordingly you will have a huge volume of data. So yeah, there is a way where you can set it up. You can actually trim down and tell Splunk that you don't want the data from past 5 days, you want it from specifically that day. You can do it. You can declare the settings, but by default it will start indexing from a very previous day. That's why same is happening today, since indexing was off for since the last class. So currently it's indexing all that data that is already there in the log file, and it's indexing it, it's getting indexed in your indexer. So that's why the CPU usage is pretty high, which it's normally it's not. It's pretty mellow. It will be below 100. It will be around 30-40. It's always underutilized. So again, memory usage, this much memory Splunk Enterprise is using, while some other process is using this much, and you have some free memory as well. So non-Splunk process basically means that these all are different other applications that's running in your system, since DMC pulls data from the internal logs, and this all data, the memory usage, and these are directly being written from your local drives. So that's why it will capture the other application data as well. Even though the data is not getting indexed, but the performance indexes are getting reflected over here. Then key value store or KV store, we don't have anything yet. We'll have a separate session on that as well. So this is the default collection that comes in there. So now what you can do is, this was an overview dashboard where you have seen all this, which are predefined searches and reports. So you can go individually one by one. So you can just drill down and see what's going on in all of this. So here you have your options of selecting your indexer. Since we have only one, it's a standalone environment, that's why we have no other option, but you have an option. So yes, so this is a problematic scenario that you are seeing here. So here it defines the indexing rate, and here it's defining a index pipeline. So what this pipeline does in very basic terms, I'll tell you is, so once the data is in, it first goes for the parsing queue where the data is getting parsed. So parsing is nothing but the data being broken down into key value pairs, and it's a huge lot of data would be broken down to key value pairs, and it will be passed forward to more modifications. So individually we have a huge session in this on this. I'm just touching it to give you an idea that, and also to justify you that 100% is not a normal scenario. It's basically a problematic scenario. So why it's this? Maybe because the indexing rate is pretty huge, or maybe there will be several other reasons which we have to troubleshoot, which we might be doing. So as of now, we just see that there is 100%, which means either the data is not flowing in a proper way or it's getting delayed. So this happens for a basic generic reason is when there's a huge outburst of data. So that's what it's happening now. 4 Mbps is not actually normal on a regular day. So that's why we are seeing this all at 100%, because it's like the final one, the index queue that you see, if this is full, then eventually the other three will be full. It's like a pipe. So if up there the exit of the pipe is blocked, then in the entrance also you will have sufficient, like it will be filled with water. So no new water volumes can enter that pipe. So similarly here also, maybe it's not blocked entirely, maybe it's flowing slow, and due to the bottleneck, basically a traffic has been formed. So even though the data is flowing, but it's not keeping up to the speed at which the data is being ingested. So that's why we always see a lag. So maybe it will go down. We'll keep a check on that. So next we can see that estimated indexing rate per source type. We can see that over a huge span of time, we are seeing only indexing now. That is at the start of the class. So there was no indexing that was being done before. and that too most are coming from the win event log security. So security files are mostly getting that is the maximum number of data from where it's getting generated. And if you remember, we are indexing all these logs in the main index. So we have enabled security indexing in the main index. So that's what the huge amount of data is coming in. So it also shows against the median the field ratio of data processing queues and the CPU usage, how it's. So you can see that what my point is, there was nothing before today and the moment we started off with our system. So it all started off when we started our session or when we brought up the Splunk. So next is again index and volumes. It talks about different volumes aspect of the indexes. You can choose by all or historical or snapshot. Snapshot would give you overview, whereas historical will give you a exposure to the historical data, and all basically covers everything. Let the system load. So wherever you are seeing a dashboard to be loaded, there is a brief synopsis defining what is there in this dashboard and defining a key meaning of it. So once it loads, we might be able to see that. Let's see if snapshot works out. Yes, it did. So we see different. So you can have an estimate that the maximum usage is being done either in the internal index or the main index, and the most amount of events are being written in these two only. And this basically explains also the bucket rollout. So exactly, so now we see what the problem is. So in the bucketing or the bucket retention policy, I'll explain it to you in detail, but for the reference I'll just tell you that we have hit a maximum number of data, and it's not yet rolled into the next event. So there's basically a bottleneck which is causing that 100% utilization up there. So we'll have to check that. We'll have to check the retention policy, and then it might be fixed. So basically it shows different stages of our data and the usage of it, and yeah, that's all about it. Volumes is, yeah, there's nothing much in the snapshot about the volumes. Shows the indexes. In the indexes covers most of the part, and these all will be covered in the respective session. So now it's pretty complicated, and there's the issue that needs to be troubleshooted. So maybe I won't complicate the tutorial with the issue in the first time. So apart from this, we have index instance in detail. Let's again come to snapshot and see. Again, this can happen index on index basis because we are having multiple indexes. So there's a difference between index and indexer. Indexer is the hardware where you are saving it. So you might have one, you might have two or three. But index is something that is logical path. So it can be multiple. In the same indexer, you can write hundreds of indexes where different types of data are getting loaded. So whereas audit is one, which is the data we are looking at. Let's look at the internal because it's getting affected badly now. See, so index size is pretty huge now, whereas audit is pretty mellow. It's just 0.02, as that has hit a huge value. So apart from that, you can see that the ratio of raw data to index size. So raw data is basically the unoptimized data, whereas index is having the raw data as well as the metadata. So which is the data that some optimization has been done to enrich the data for all the performance. So that's why the raw data to the index size is pretty huge, if you can see. So as of now, okay, no, it's pretty less, because raw data is getting morely consumed. It's all because of the issue we are having. Let's see the same in the audit as well. Yeah, in audit we see the ratio is raw data is less. Let's go to the main and see. So main is not showing up anything strangely. Okay, so there might be another reason is the data is getting not written to index. So as a result, you have the raw data, but since it's not getting written to index, so the entire raw data has not been transformed to the indexable data. So that's why in index you have less amount of data. That's because of the bottleneck we have hit. So ideally, the raw data size should be less than the index data, which we see for the audit. But it's strange that the main data is not showing up. Let's hit all and see. It's basically giving a bucket count, and also it can't be 0 GB as we are having the events count. Basically, it might be taking some timing quotient not properly. So yeah, so it's this dashboard. Again, we'll come to this once we have covered the bucket retention policies. Meanwhile, there are a lot of components over here which might not be that clear as at this point of time. So we'll come to this once we have covered the bucket retention policy, which is a part of this course. So let's see the license usage over here. Yes, so basically what it's showing is today what is the used part of the license and what is the quota. So we have this as the quota, whereas we have used just a part of it. So it's not at all hitting the threshold. So we are well below it. But it's just the data for last 30 minutes. Maybe over the entire span, maybe we'll breach the threshold in fact for the day. So let's see that. So this is the percentage of usage of the total pool. So we have only used 6.27% of the total quota that has been assigned. So current quota is 500 GB, that's like 500 MB, but we have maybe the 6% of 500 MB. So yeah, so it's well below. It's around 30 MB, around 40 MB. So it's pretty below that. Okay, again this is low. Even though you see this huge amount of indexing, you might be asking yourself that how come this is so low, whereas the indexing rate is 4 Mbps. How come? It's because the 4 Mbps is mostly being consumed in the internal index, as you have seen, and I have told you the internal indexes does not count for license usage. So even though you have a huge inflow of data, but 90% of that is coming from the internal index. So main might have been using this only, whereas the main has not written that much. So that's why the license usage is pretty mellow till now. It's around 40 MB. So you can understand the main contributing factor for that huge indexing rate is the internal index, which is basically taking the historical logs into the fact and trying to index that into the disk, which is causing all these issues. So that was about the indexing performance. We can also see the search performance similarly. Maybe we don't have any external search written or customized search written, so we might not see any, but there are searches running in the background for the DMC. So these all are the searches that we are running, if you can understand. So when you are loading the dashboard, it's showing that searching, waiting for the input. So that's a search. So these dashboards are something that we have not written maybe, but these are being coming as a bundled. These are bundled with the app itself, the Splunk app, when you download. So when you refresh the page, every time you refresh the page, a new search is hit. So that obviously will be counted as a search. So that's exactly what's happening over here. So even though you are seeing that there is nothing much in there, but that's because we are not running any customized searches. So that's why it's pretty less. but you can see that the search concurrence is pretty high. That's because these all are internal searches. All these are internal searches. Whereas ad hoc searches is only 3. So ad hoc is something that we are running for extra. So these are all time searches that has already come built in within the app and which is supposed to run 24/7 until we shut down the Splunk server. But these were ad hocs, which was not part initially of the app and which we might have configured. Okay. So this is what you have got as of now. So we can also drill down in multiple other aspects, which again will covered in a specific class when at the end of the entire session, when DMC would be more understandable. So similarly, you have the resource usage by instance or by machine. Let's give a quick look into this as well. And we have forwarders, which we might not be touching now because we don't have in forwarder instance only. Forwarders, as we know, we have covered that it gathers data from the remote logs and forward to the indexer. So we don't have any now because we are indexing local logs, so there's no point in going there. Settings is the basic settings of different setups, and we'll again cover that in the upcoming sessions. As you can see, the resource utilization being showing here, that how Splunk D is using the main Splunk daemon server, searches how much it is consuming these again, and internal searches, scripted inputs. These are the inputs from where the logs are being picked up, the local inputs. There are some other irrelevant maybe process running that is being picked up here, and the KV store, the key value store, which is running parallelly with the searches. So searches picks up data from the key value store. We'll come to that as well. CPU usage by process class. So main two things that are using the CPU usage is the Splunk D and the search, because these are happening real time, whereas the physical memory is being used across these classes. So it is showing an estimated how much D is consumed for you. If you come back to your my computer and if you can cross check it, you should see the same. So it's pretty similar. It's 47.7. Here also we are seeing similar data out of 199 GB. So yes, so it's the same. And since we have installed our Splunk in the D drive, so that's what it's showing up. These are all process related data that we are showing up here from your machine or the hardware perspective. Then you can always run a manual search on your own. That is always possible in the Splunk Management Console app. Okay. So that was a quick overview of the DMC, or the Distributed Management Console, and what is its power and what all you can see over here. Lot of issues can be tracked from here itself, like the way we have now on the search bottleneck, which obviously I need to check and see. So now again, see, we have a 6 searches running parallelly. That should be because we can go to the jobs and see. So each jobs is being powered by a search. So whatever job we are talking about is being powered by a search and it's running at the current time. So these concurrent searches or parallel searches has contributed to that count in the DMC. So that's why you can see the concurrent searches means basically the parallel searches that is running, and there's a limit in that. So when you are configuring Splunk, it will come with a limit that this is the maximum number of searches that you can run parallelly. That is how it happens. So as you can see, the license usage is increasing. That means the data is getting indexed with the license. So even though we have seen that we have hit a bottleneck with 100% pipelining, but even then you can understand that data is actually moving but in a relatively slower pace. That's why we are seeing always 100%. So it's like our maybe judicial system, where always there are cases pending. So even though the cases are processing, but it's with a lag or a delay. So always there are people standing on the line. The same is happening over here as well. So let's once again take a look at the snapshot and confirm the same. Again, this slowness that you're observing now, this is purely because of the hardware. The better the RAM, the better the IOPS speed that we are having, so better would be the performance. So this is purely based on your machine performance. So now I'm not having a very high profile hardware. That's why I don't have that huge perfect speed. But if when you're actually procuring Splunk and we are utilizing different hardwares, you have some recommended set of hardware that comes with it. So if you start utilizing those, then you won't have to wait this long for the searches to happen. So it's still 100%. So that means we have still the huge outburst of data, which actually I can see. So 1000 MB, 1 Mbps is not very for our license, it's not very usual. So it's for a setup, in fact. So it's basically it's writing the historical logs. So now again it's shot up to 4.5 MB. It's huge. Fine. Let the data get indexed. Meanwhile, what we'll do is we'll come to the settings and check the distributed environment. So what is a distributed environment? If you remember my early classes, I have explained you what is a distributed environment. It basically is a clustering that is being done across multiple indexes across. So if I open the PPT, let me walk you through. So this was the distributed model. So Splunk distributed model has different servers identified for specific Splunk components. So we have dedicated indexers, search head, and master server, and all those things which we are having in the same server now. So there are various ways in which we can scale it. Yeah, obviously. So the primary constituents are given search head, from where search happens. Search peer is basically the indexer. The forwarders, where the forwarders are getting logs are getting forwarded to the indexer, and obviously you have license master, deployment server, and a deployer. So all these components come into the picture. There's a repeat of the license master. Okay, so finally you have the universal forwarder. We have talked about it or two. Yes, so all this Splunk server, as I told you, would communicate with them, different Splunk servers, via these ports. So the opening of these specified ports are very important. So now let's come back to this page where we have the clustering. So there's no point in enabling the clustering because we are not having the multiple instances. But I have saved some screenshots for you to show you how it actually works in real-time environment. Yes, so this is indexer clustering. So what it does is when you enable the indexer clustering, it will ask for replication factor, search factor, security key, and a label. So what we can give is we can give replication factor, so which will hit to that soon. I'll tell you in basic that suppose you have 3 different servers to index, so you have 3 indexers, but you don't need always, so these 3 indexes will have the same set of data. So these are basically for high availability, so that one goes down, the other 2 at least will have the same set of data from where we can search it. Now there are multiple factors that come in over here. So if you have more than 3, suppose you have 5 indexes, then there is no point in always keeping the same set of data in all 5, because it won't be that scenario where all the 3 or 4 of them will go down simultaneously. So there is less chance in that. Yeah, even if it hits an earthquake, a natural disaster, in that case you can do a multi-site where you will have different indexer in different locations, where you can at least if you have 4 locations or 4 different indexer, if 2 goes down, other 2 are active. So what my point is, if you have more than 3 indexes, there's no point in keeping the same data in more than 3 indexes. So it's highly improbable that all 3 will go down at the same time. So that's why these factors come in over there. So replication factor, search factor, these means that the data duplication won't happen in all of them. So when you have 5 indexer, maybe in 3 of them the data duplication will happen. In other 2 there will be some amount of data but not all. So immediately when one of the indexer goes down, there will be a master node which will dictate a third indexer and will bring it up, and the replication would be done. So at that point of time, even you have 4 indexers in total, 3 of them will be up with all the duplicate data. So again, if another goes down, again you will have 3 indexes with all set of duplicate data. So the master controls that. Master tells that indexer to start gathering data from other 2 indexes. So that is how replication factor is defined. It actually replicates the data across indexes. With 2 means how many indexer it will replicate to. So for a specific environment of 3 indexes, 2 replication factors means always 2 of the indexes should have all the raw data. So if A, B, C, 3 indexes are there, and A and B are the primary indexes which is having the replication data, and A goes down, immediately C will start getting the duplicate data from B. And within a certain amount of time, B and C will have the entire set of duplicate data. That is because if at some point of time B also goes down, then C will at least be having the data which will help Splunk, which help the users to search the data. And the meanwhile, the expectation is to bring back A and B. So that's how a high availability disaster scenario is done in Splunk. Search factor is similar concept of replication factor, but just that replication factor just deals with the raw data, whereas search factor deals with the searchable data. So there's a difference in that. The searchable data is the metadata plus raw data, as I have told you, and it's a very premium data, and its sizes are huge. So if a normal set of data size is 10 MB, the searchable data for the same will be 40 MB. So all those summary indexing and all those report acceleration, all those factors pitch in over here. The search factor is basically an optimized data and very you can tell it's a very cooked data. So it's been lot of materials has been added to the data to make it easily searchable and optimized data. So that's why the search factor, keeping a huge value for search factor actually means that your huge amount of space would be eaten up. So again, search factor is something you can keep for 3 indexes, you can keep 2, because suppose A and B are searchable, the moment C is has to come up because one of the A or B is down. So that C will have start the replication of data, and the searchable data parallel will happen in C. So it's a complicated process. It might take maybe 4 hours, 5 hours, 6 hours depending on the data that you are having. So in that 6 hours, C will be up and ready for handling the search request. So basically, this is an alternate scenario. If in case of something goes down, this is how it needs to be done. This is how it happens. So that's why this is important to declare these two: replication factor and search factor. Security key is something secured handshake happens via this key. So always when two of this or multiple of these Splunk components are communicating, they communicate first with the security keys. They make sure the security key are aligned. Then only they'll go forward. This is the internal authentication that is there with Splunk. Cluster label is something you manually declare for the indexer cluster. Or if you have a 4 or 5 indexers, you can give all 5. You can pull them into a group and you can name them. And you can have separate groups of 2 and 3 indexes. Again, you can name them separately as well. There are organizations that are running maybe 500, not 500, I stretched it, maybe 50 indexers. And there might be possibility of huge 500 indexes as well, such a huge environment. So 50 indexers, maybe they have divided it into different clusters. Maybe it has divided it into 3 clusters, one 15, another 20, and another maybe another 50. So in that case, cluster label comes up. So that's all you can do in the indexer clustering. And once you have set it up and you restart the Splunk, you will have to define the master node as well. So the master node is something that defines who is gonna dictate all this. Who is gonna tell if one of the indexer is down? Who is gonna tell you that okay, boss, this indexer is down, so start the third indexer or start the C indexer with all the replication and the searchable data. So the master does that. Whenever the master sees that one of its indexer is down, so what master does is at a regular frequency it will ping its indexers, its search peers, and it will see if the ping is coming back, and if all the servers are up and running, it will not do anything. But suppose there is an issue, so immediately what it will do is it will give all this command to the other indexers to start replication and searching of the data, as in to convert the data to the searchable data. So all this is being controlled by the master. It does that by the its port 8089. Yes, and here also you have to give the security key. just to make sure that your data is secure. So this is master URI is something where you are where you are defining the port number of that server. Again, for search head, so now when we are doing indexer clustering in different places, we have to do it in a different way. So when you're asking for indexer clustering, it will let me enable that. It will hit you with the first three options. One is the master node. So if you want this node to be a master, so if you want so, then you have to define these factors that I told you: replication, search factor, security key, and cluster level. If you don't want it to be a master node and want to be an indexer or the peer node, you have to declare this master URI, the replication port, and the security key. Master URI is the master. Whoever is the master, you have to point it to that with the management port, that is 8089. Replication port is nothing but how the replication will happen between A, B, and C. Which port would be opened to make sure the data flows internally between them to get it replicated. So this replication port you need to define and open it. And security key, as I've already explained, is to do the manual handshake. But if you want it to be a search head node, then you have to define complete new set of data. You have to again define the master URI and the security key. Search head node is basically from where the search requests are being handled. So search head also communicates with the master. So that's why master URI is important for both indexer and search head. In indexer you see master URI. In search head also you see master URI. So search head also, when you are asking for a search request, it comes to your master first. Master sees that what is the type of search. It then runs a scan on all the three indexes and it forwards the search request to the most suitable indexer. So suppose I tell a scenario where you have three indexes A, B, and C. Now C is not having all the set of data. A and B are having the data. The search request has come in. It comes to the master. So master first checks, okay, this data is not there in C, so no point in sending it to there. So it will send it to either A or B depending on the load balancing. So suppose A is already loaded with 5 search requests, so it might send it to B. Maybe B is not that used as of now. So in the relative usage, it will forward the request to them. So that is basically how indexer clustering works. I just kept the screenshots just to make sure, since we can't do it in the real environment, so that at least you have a grip on this. So once this is set up, this is how it will see. You will see it. Yeah, so and different indexers and search heads, and you will see in search head you will see the master is up and all data is searchable. The search factor is met, that is two of those indexers are up. So if you see that one indexer, only one is up and running, then it will be not met. If the replication factor is up or not, so all this will be comprehended by the counts that you have justified in the master node. The status is up, so all this will be the resultant uh, reflection in the different nodes. So that was mainly about indexer clustering. So next we'll just take a peek into the forward management. It is nothing but managing the forwarders from a maybe a remote location. So basically, so you have multiple forwarders, right? And these forwarders are distributed over huge amount of sources. So there can be a range of 500 to maybe 10,000 forwarders. See, you can understand how hard it is to push a setting to these forwarders. So you might have to go to this individual 5,000 forwarders and deploy the setting if you have a change in the settings. So that's why this forwarder management console has been built on top of the forwarders, which lets you handle all the remote forwarders from a consolidated centralized console. So we'll get to more about forwarder management in the respective classes. Again, distributed search. So this is basically is suppose you have the indexer clustering. Same you can do with the search head clustering. So suppose you in your indexer, multiple indexer, you clustered it and found it for the disaster recovery and the higher availability, right? Same you can do with the search head as well. You can have multiple search heads, so that when you have multiple users, so from 100 you have a range of 5000 users, Splunk users. So in that case, one search head might not be enough to handle all the requests and all the business that asking for. So in that case, you form a search cluster which is having multiple search head. Each will be called as search peers. And similarly, as we have the master node which dictates on the search heads, we will have uh, a deployer that will do it for. So we had it in the presentation, if I remember correctly, a deployer was there. So deployer basically controls. So yes, this is what the deployer is. Deployer is like a master for the search head. Suppose we have a master, so master license master is different. We have a master like cluster master which takes care of the indexer cluster. Similarly, deployer takes care of the search head cluster. So that's what exactly we do over here, distributed search setup. We have a distributed indexer setup, we have a distributed search setup as well. So we just covered the distributed management console and the distributed environment, some basics on that. So since we don't have a distributed environment with multiple servers, we had talking about a standalone server over, like what all I show you is in a standalone server. So this is basically for a distributed full Splunk console. So let's open the web console, log in with admin credential, and here I am logged in. So you might have noticed one thing that I just wanted to add, that we are not using HTTPS, we are using HTTP, which is not a very secure connection. So you can always undo that. You can upload your choice of certificate or the default one that comes with it. So anyway, for that you have to enable the HTTPS secure connection, for which you don't have to do much. You just have to go to server settings, general settings, and you have to click on the enable SSL in Splunk web option as yes. So if you remember in earlier classes, we have changed the default web port from 8000 to 7000. So in the same place we are coming and doing this thing. So let's save this, and we might have to go for a restart, which Splunk is prompting us anyway. So it says that Splunk must be restarted for changes to take effect. So you can directly restart from here, or you can use the command line maybe. So let's do it from command line, since that is one good thing to do. You can always start it as an administrator. So you need to go to the Splunk home path and do the restart. So as you know, it's in the D drive, D Splunk directory. So in the D drive, you go to Splunk, we have to go to OPT. Yes, so CD Splunk it should be. Okay, it's not found. Should be there in the D drive. Okay, yes, so it's in the program files. I just recollected. And then you have to go for Splunk. So I had other folders for which I got mingled in. So now we're in the Splunk home path, that is the D program file Splunk. Now we have to go to the bin directory, because all the executables are there in bin. So any command that you have to run, you have to always come to the bin directory. So first let's check the status of Splunk, which should be running. Yes. Now we will fire the command for the restart. So remember, this is the Windows version of the command. If you are using Linux, it would be a tad different, but it will be habituated with that. So we have initiated the command. We should see that it should be in effect soon. Let's wait for the restart. So as you see in the web also, Splunk is down because startup process is in progress and Splunk D is starting. So you will get to see all the steps, ongoing steps over here, which will give you an estimation what all is going on in the background, and if somewhere the error is there, you will readily get to see that in real time. This is going to take a while. So we have got this one started. So let's start to reload the page, which would obviously say us. So if you can understand why is it unable to connect the same page, that's because we have changed the settings. We have brought HTTPS, it's now HTTPS. So that's why we won't see the other link to be worked. So this should be the right one. Okay, this shouldn't have been. So that's there we use CA. Whereas if we try the same for the earlier version, you won't see anything because we have changed the settings and you don't have anything in this board as of now. Fine, let's do a login. So this is the only change that we just made. There was no other significant change that you'll observe. Now anything that you do would go through a secure connection. That's it. So let's go to the part that was left in the previous section, that was the access control or the users and authentication. Yes. So what is user and authentication is basically how an individual access Splunk and what are the roles he has been exposed to handle Splunk. So as you can see, I am opening Splunk with a admin access. So there are several other layer of roles that you can take leverage of. And there are other different authentication methods as well. So I'll just give you an overview of the authentication methods. We'll not go deep into this right into this class because we have a separate class for that. So the primary or the default one is the Splunk native authentication. That is the internal authentication Splunk, which is always on, which you can uh, at any point of time you can roll back to that one because it will by default be always on. So apart from that, if you want any other external authentication, you have these two, the most possibly used external authentication methods, LDAP and SML. So there is a procedure to configure the LDAP or SML connection with the settings that will be provided to you. So there are various sources of this settings. I'll give you an example. I'll explain with you an example on the detailed class. Similarly, for SAML access as well, you will have to fill up the form which will enable the SML authentication. So you can use this one or any of the other two. So this is how you access Splunk. So we are using the native authentication, that is Splunk built-in one. Okay. Now the users. So what are the users is basically there are multiple tiers of user that can access Splunk. So now as you see, we just have one admin access that has been created by me for my reference. So similarly, an admin can give access to multiple other users. So how the access is being given is you add a username of according in line with the requester ID or requester name. You give the full name, the email ID is a generic thing, time zone, obviously which time zone you want the user to be in, because whatever searches the user would be doing will fall into that time zone. Obviously the user can go ahead and change the time zones as and when required, but yeah, this is the default one that you will set up. Also the default app. So once the user logs in, which app would he see? As we log in, we see the search and reporting app that is there by default. Okay, no, yeah, we see the search homepage because nothing has been set up. So these are the three options that we have as of now: the Splunk Management Console or the DMC, the search, and the launches. So any of these app, if you want to readily get access to once logged in, so this would be set up here. So in a lot of organization, there will be multiple added application that are used. Suppose an app for the dashboard, and maybe the organization wants that once they log into the Splunk, they want to see the dashboard. So those things can be done from here. Now another part is assigning roles. So these are the prime roles that are available in Splunk. The admin role, the highest privilege role, which can do almost anything. So this is the highest amount of access that can be given to an user. Can delete. Okay, this is a special rule that had been carved out of admin, that is can delete. So even an admin cannot delete uh, an index, because index is a very sensitive thing. Once you delete an index, there is no going back, so all your data is lost. So the delete command used in Splunk is a very prime command, and it cannot be given to even an admin unless requested or he's responsible enough. So from a business point of view, so can delete is an added role that is given to the admins who needs to delete indexes. So this is the role. Power users have is like a generic user, but with some extra activity access. They can create and share the knowledge objects, as in the alerts, the dashboards, the reports, and also their reports would be given a preference. They can view and edit reports which have been shared with them. So these are the some of the main uses of the power user, whereas a normal Splunk user won't have such access. They might be able to create the knowledge objects locally, but it won't be possible for them to share them. And also the number of concurrent searches for all these roles are different. So how many users doing parallelly how many searches would also depend on what all access each of them gets. Also the Splunk system role is a generic role for the Splunk system users. Now you can always give multiple role to the same person. Suppose you want to give user maybe a can delete and a power role to a selected user. So you can choose these two, and you can go ahead. So these two has been added as a selected role. So this way roles can be added. Also you can create a new role. So completely, suppose you have created this with these two available roles, you are creating a completely new genre of roles, and maybe you need to give it to multiple people, maybe not one, maybe five. So you create a new role along with the user. A new role would be created, which you next time when you log in you might see up here in the available role section. So on checking this box, you will get get to do that. Next is set password, which is some generic password that you will be configuring and you will be sharing it with the user. So this is how basically you create an user for Splunk native authentication or Splunk built-in authentication, which the user would use, and accordingly he can react. Also roles, as you have seen in the user section, also we can add roles, and there's a separate section altogether where you can go ahead and add new roles. So you have a role in mind, you give it a name. Suppose it's for the security user, so you give it a security personnel. Then give the default app again, which app you want the user to be in when he logs into the system. Next is restrict search items. So where all he can search and cannot search. So those terms can be restricted. You can use the Boolean terms such as and, or, and you can always mention that these are the places, this is the host, or this is the source type that he should not be accessing. So here you basically restrict an user to some specific portion of the Splunk. So you can customize. You are basically customizing the access of the user. Restrict search time range, which is set to -1. So set a maximum time window for searches for this role. So it basically means that suppose, for example, set this to 60 to restrict the role searches to 1 minute before the most recent time specified in the search. You can also set this to 0 to explicitly make the window infinite, or -1 to unset the window for this role. Can be overridden by imported roles. So basically here what you are doing is you can declare the maximum window for searches for this role. So how big this user can search, suppose for 60 minutes, maybe for 1 hour, 2 hour, the window of searches and that has been given access to this user. So you can set it to 0 for unlimited access, whereas given -1 means that the window for this role, to unset the window for this role, so this user might not be having any window assigned to him. So there are other levels of explanation that needs to be given for each of this attribute, which we will be again covering in the user specific class. Yes, we'll also come across the inheritance and other capabilities. So this is a very light overview of what all can be done and what all are being done with the Splunk user roles.
Now, Splunk is one of the booming technologies. Its growing demand and suitability to candidates having diverse educational background makes it an attractive field of opportunities. So, as you can see in the graph, there is a drastic change in the requirement of Splunk professionals from 2012. Some of the prominent Splunk job titles are Splunk Architect, Splunk Admin, and Splunk Developer. So, the time is ripe to upskill in Splunk career opportunities that come your way. Learning this technology will ensure your success in the near future. So what are you waiting for? Join our Intellipaat Splunk training course today and become a Splunk professional. This course will help you to understand the weblog analysis, design reports and charts. You'll also learn how server configuration is carried out in Splunk deployment.
So this brings us to the end of this session. If you have any queries, please do comment below. We'll reach out immediately. Also, subscribe our channel so that you don't miss out on our upcoming videos. Thank you.